All right, so last week we talked about the different phase changes and the different phases of matter, solid, liquids, and gases, except there's another state of matter that we use in chemistry that's associated with solutions. And normally when we're talking about a solution, a mixture of two substances, we're usually talking about an aqueous solution or one that's dissolved in water. So we usually represent it with parentheses around AQ, which stands for aqueous, meaning something is dissolved in water. Okay. And a review of the other phases of matter: if something's a solid, S in parentheses; if something's a liquid, lowercase l in parentheses; and then a gas is a G in parentheses. So for an aqueous solution, it means it's dissolved in water, and it means that water is the solvent for an aqueous solution. And a solvent is the dissolving medium. Okay, it's what's doing the dissolving in a solution. Then the solute is what's being dissolved. So in terms of measuring the concentration of a particular solute or something that's being dissolved in a solvent or in a given solution, which is the total, the solute and the solvent combined, there's a couple different ways in which we can measure that. The first way is molarity, which is represented by a capital M. And it's the moles of solute. And we're going to talk about moles more later next chapter, but moles is just a measure of amount. And we're going to talk later how we convert from mass, from grams, into moles. So it's that amount of solute, the amount of what's being dissolved, divided by liters of solution, so the volume of solution. And remember that unit has to be in liters, not in milliliters. So if it's in milliliters, you have to make sure that you divide by 1,000 to convert to liters. And this is the total liters of solution, meaning it's the volume or liters of solute and the volume of the solvent as well. So that all together. So for example, with molarity, you'll see the unit sometimes as capital N, sometimes you'll see it as capital M or moles over liters as well. And so for example, let's say you have 1 mole of CaCl2 dissolved in 125.0 milliliters of solution. And sometimes you'll see solution abbreviated like so, SOL, apostrophe N, and you want to calculate the molarity. So that means we take the moles of the solute, so that's CaCl2, calcium chloride. That's the solute, that's what's being dissolved. And the 125 milliliters of solution, we need to make sure we convert that to liters, divide by 1,000, so that becomes 0.125 liters of solution. And notice I did not say you have 1 mole of CaCl2 and 125 milliliters of water, because that wouldn't allow you to calculate this problem, because that 125 milliliters of water would just be the volume, or liters, of solvent, and not the solution altogether. So combining the two, CaCl2 and the water, that would produce a volume that was larger than 125 milliliters. Okay, so now we do this calculation with the correct number of sig figs, so it's 8.00. We would call it molar, so either use that unit of capital M, or you could put moles over liters. So this is an 8 molar solution of CaCl2. However, I could ask you, what's the concentration of each ion? So sometimes you'll see this concentration or molarity. Sometimes you'll see it represented in brackets. So let's say I asked you for the concentration of the calcium ion, the Ca2 plus ion. If you look in CaCl2, for every CaCl2 formula unit, for every CaCl2 compound, there's one calcium ion. So that means the concentration of the calcium ion is the same as what it is for CaCl2. So that's 8 molar. However, if I ask for the concentration of the chloride ion, it would be different because in CaCl2, the Cl2 part, there are 2 chloride ions in every formula unit of CaCl2. So that means, in comparison to the concentration of CaCl2, you have to double that, multiply it by 2, to get the concentration of the Cl minus ion. So the concentration here would be 16.0 molar if I asked you for the concentration of Cl minus. Okay, now there's another equation that goes along with molarity, and that's called the dilution equation. And this is an equation that's used most often when you're making solutions. You have something that has a high concentration, like the 8 molar concentration we just talked about, and let's say you want to make it 4 molar or 2 molar or 1 molar. So in order to dilute something, in order to make it less concentrated, you add more solvent, or normally our most common solvent is water, so you'd add more water to make it less concentrated. So with the dilution equation, it's M1V1, or the initial molarity, the initial concentration, and the initial volume, is equal to the final molarity and final volume. So M2 times V2. So for example, let's say we have 250 milliliters of a 5.75 molar sugar solution. Okay. And we want to dilute to a volume of 0.5 liters. And so now we want to know, what's the new concentration? What is the new molarity? Okay. So that means we're solving for M2. We rearrange our original dilution equation, so it's M1 V1 over V2. So that means our original concentration, our initial concentration, 5.75 molar. Our initial volume, 250 milliliters, but you should realize the initial volume, 250 milliliters, the final volume, 0.5 liters, those units do not match up. So we need to make sure they match up. And for this equation, it doesn't matter if they're both in milliliters or both in liters, as long as they match. So we could either convert the 250 to liters. If we did that, divide by 1,000, so it would be 0.25 liters over 0.500 liters. Or we could convert the 0.5 liters to 500 milliliters. Okay. So finally, when we do this concentration, you should get a final molarity of 2.88 molar. And this answer should make sense. We know we're starting with a lower volume, 0.25 liters or 250 milliliters, we're increasing the volume to 0.5 liters or 500 milliliters. So that means as that volume is increasing, as we're making it more dilute, the concentration should decrease. Now for mass percent, you're simply taking the mass of the solute, what's being dissolved, dividing by the mass of solution, and multiplying by 100. Right, so let's say we want to know what's the percent by mass of glucose in a solution. So you're dissolving 5.5 grams of glucose in 78.2 grams of water. And here's where you have to be careful, because here I said 78.2 grams of water, and water is just our solvent. So this is not the total mass of solution. The total mass of solution is the mass of the solvent, water, plus the mass of the glucose. So for the percent by mass, we take the mass of our glucose, 5.5 grams, and divide by the total mass of solution, so the mass of the solvent, plus the mass of the solute. So you have to be very careful when reading these problems. Is the mass given to you just the solvent, or is it the solution as a whole? And still always here, make sure you don't forget to multiply by 100. And finally, with correct sig figs, the answer here is 6.6%. Okay, now last one. The last way to measure concentration is molality, which is different than molarity. Remember, molarity was represented by a capital M, whereas molality is represented by a lowercase m, or in terms of the units, you'll see it as lowercase m or moles over kilograms. And for this one, it's moles of solute over kilograms of just solvent, not the solution. Okay, so that's the way that molality and molarity are different. They both are the moles, the amount of solute, what's being dissolved. Molarity deals with the liters of solution, which is useful sometimes because it's the overall volume of the solution. Okay. So for example, let's say I want to know the molarity. If you have 3.4 moles of sugar, and dissolve it in 100 milliliters of water. You want to know what's the molality. So first, before we do that, okay, we know we have moles of the solute, moles of sugar, except kilograms of solvent. Here we have the volume of the solvent. However, you should remember the density of water, of liquid water, is 1. So using that, we can convert this 100 milliliters to mass, to grams, because we know the density is 1 gram per milliliter. Okay, so since we have 100 milliliters, 100.0 milliliters, we have 100.0 grams, but we need to make sure that mass is in kilograms, and we know for every 1 kilogram, there's 1,000 grams, so that means our final mass of water is 0.1 kilograms. So we use that to put into our molality equation. We have, once we take 100 grams divided by 1,000, that equals 0.1 kilograms. So that's our denominator, that's our kilograms of solvent, and then 3.40 moles of sugar, or moles of solute, is in the numerator, and you divide that out, and you get a final molality of 34.0. You'll either see it, remember, as little m or the units of moles over kilograms. So those are the different ways in which you can measure concentration. And normally our most common solvent is water, so you'll see all of these as aqueous solutions, and remember that is abbreviated by AQ. See you next time.